What's going on YouTube? It's your boy Sammy B. This is my first video, so I'm a little nervous. We're gonna be talking about some programming stuff here, so don't feel like you don't know anything because we're all learning together here. This video, it's gonna be a little scatterbrained. I'm hoping that in the future my videos kind of converge, like a PID controller or something. This channel is gonna be dedicated to programming, Linux. Just anything really just geeky. A lot of the videos are also going to be dedicated to like investments and data science, trying to figure out how to make your money work for you. So that's going to be a huge topic as well. I'm going to make this video here in the future showing you guys how to build a like a $10 security camera with infrared text message alerts. So if that's something you want to see, then make sure you subscribe and support the channel. This video is going to be dedicated to finding profitable trading signals using programming. It's just a great way to visualize your data and see if there's any relationships between technical indicators and future returns. Without any further ado, let's go ahead and get into it. I'm going to show you guys a little picture. Basically, this is my idea right here. Take a look. We're going to be making these 2D histograms with the future return on investment plotted on the y-axis and our study variable plotted on the x-axis, and the number of occurrences will be in the center there. So this is just a picture I found on the internet, but this is basically what we're looking for here. There's a clear correlation wouldn't be the right word, but there's a clear pattern here. So remember, we're going to be plotting the future return on investment here on the y-axis and our study variable here on the x-axis, and the color just corresponds to the number of occurrences, or the count in this case. So this is basically what we're looking for. I actually haven't been able to find one that looks quite this good, because most of the study variables I plot kind of just follow the normal distribution. There's not really much of a indication of whether there's going to be a positive future return or not based on just whatever variable I'm looking at, whether that be the RSI, even the first derivative of some of the variables, or like the population skew, or the first derivative of population skew. A lot of those things don't really indicate that there's going to be a positive return on investment, but this right here is basically the holy grail. This would be the holy grail if we found this, because as you can see, we're interested in everything above this 0. That is basically a positive return on investment, and these variables over here would correspond to a positive return on investment nearly 100% of the time. You see, every time this variable occurs, there would be a positive future return on investment, however many days into the future we go. So this would be the holy grail if we did find it. But as you guys will see when we start coding, this is hard to find. I'm actually not sure what this is a plot of. I just found it on Google. So let's go ahead and write some code now and get right into it. So before we get started, you're going to want to make sure you have pandas installed, as well as matplotlib, and also pandas_ta for the technical indicators library. That's just a pip install. Just these right here. That's all you'll need. Make sure you install that in like a virtual environment or something. I'll go ahead and make a video at some point showing how to set up Sublime with your build system and your Python virtual environments, just so you don't interfere with any of your system Python libraries. Okay, so once you have those installed, let's go ahead and import pandas. Also dot damn. Now we also want to import pandas_ta as ta and as PD. That's just the standard protocol, I guess. So now we want to go ahead and import our data set. pd.read csv btc usdt underscore one day.csv. This is the 1 day data set, and I'll go ahead and link this in the video description, so if you want this data set, go ahead and download it and put it in your working directory. Go ahead and run that, and let's see if there's any errors here. Okay, good. Okay, before we get too far, let's go ahead and plot what exactly we're looking at here so you guys have a better understanding. Range len df.close comma df.close tlt.show. So we're just gonna go ahead and plot this so you guys can see actually what we're looking at here. Just the price of Bitcoin in USD. That's it. That's all we're doing. So here's our data frame. We got 14 columns, just the timestamp, open, high, low, close, you know, date, time, volume, all the normal stuff. So we're gonna go ahead and drop a bunch of these columns, and I'll show you how to do that real quick. So if we print our columns, we'll see all the columns we have. We're gonna just keep the closing column, and that's all we're really interested in here. So for call in df.columns, print call. Okay, so now instead of just printing your columns, we're gonna put a little piece of logic here. So if call is not equal to close, now if that's the case, we want to go ahead and df.drop call axis equals 1 and in place, dang it, I keep fat fingering things, sorry, equals true. I'm not the fastest typer. I'm probably sitting around 40 words a minute, so you're gonna have to bear with me here. Print df.head. There we go. So here's our data frame. All we have is the closing price and the index, and that's it. So now what we're going to do is we're going to create our future price column, and from that we're going to create our future return on investment column. So then we'll have the y-axis, and then we can go ahead and just play around with the x-axis and see what we get. I'll show you guys how to do that here soon. So we're going to make a variable called days to shift, and we'll just set that equal to 2. So this is basically just the number of days we're going to shift our closing price. What I mean by that, I'll show you here in a second. So df future price equals, we're going to use the df, we're going to use the shift method. Df close dot shift, and then you want a negative sign because we're shifting it negatively, and then days to shift. So go ahead and do that. Now we have print df dot head. So now we have our price, and then 2 days in the future right here is shifted forward 2 places, so now it's up here. You see that? Okay, now that we have this, we're going to go ahead and apply this percent change formula using the apply method. So basically the new value here is going to correspond to the future price, and the old value is going to correspond to the closing price. It's kind of weird and counterintuitive, but that's basically what that's by definition. So let's go ahead and use that. So you want to make a column called future return on investment, and that's going to be equal to df future price actually, wait a second, we don't want to do it on just the future price. We want to take the data frame and use the apply method. Apply lambda row colon. Now this is where the formula goes. So this is going to be row close, right? No, it's going to be row future minus row close divided by row close. And then you got to specify your axis equals 1. Okay. Now print your data frame head. And something's wrong here. That's not right. Maybe we need some parentheses. PEMDAS. There we go. Does that look right? Yeah. Yeah, this is negative. It's less than here, and it's a negative return on investment. Okay, that looks right. Okay, so you just need some parentheses. You know, order of operations. What a pain in the butt. Alright, so let's go ahead and continue on. So now we have our y-axis. Now let's go ahead and create a study variable. Now this can be anything. This could be any technical indicator. This could be a simple moving average. This could be a derivative of a technical indicator, a first derivative. It could be a statistical measure like population skew, kurtosis. It could really be anything. Alright, we're going to just start off with something real easy here. We're just going to start off with, I don't know, the 15-day simple moving average. Now, to do that, all you do is take the close and then dot rolling window equals 1.5. Oh my gosh, 1.5, and then dot mean. Okay, so that is the 15-day simple moving average. Mead. Okay, there we go. The simple moving average. This isn't a great example because obviously, if whatever the simple moving average is, it's not going to really correspond to any return on investment. It's like, this is kind of a bad example, but it'll allow you guys to understand what's kind of going on here. Obviously, the simple moving average is statistically insignificant. It doesn't mean, like, if the simple moving average is whatever, that doesn't mean that 2 days in the future there's going to be a positive or negative return. You know, like, that doesn't even matter. So just keep that in mind. But this is a super simple one to do and super simple to show. So let's go ahead and print the data frame.head now so you can see. Oh, we also have to drop these nans. There's some nans here at the beginning, and there's also some nans at the end because we shifted the closing price. So we're gonna have to go ahead and df.drop na in place equals true. Oh my gosh. Okay, so now let's go ahead and make this 2D histogram. Okay, here we go. So plt dot hist 2D. Now it takes a few parameters. This is your x-axis variable, which is going to be 15 SMA, and then df future return on investment. That's the y. Now we need to specify the bins. I'm just going to go with 50 and 50, and then Vmax, I'm just going to go with 10. Oh my gosh, okay. Now plt.show Okay, here we go. Here's our first histogram. We also need plt.color bar. Okay, so we need bins equals 50/50. Oh. So here we go. Here's our first histogram. Like I said, not a great example, but this is what we are creating. So you see it's kind of centered around 0. So it's kind of normally distributed, if you will. I don't know if that's the correct term to use, but there's obviously no relationship between the moving average and future return. So this is not what you're looking for. Just keep that in mind. Anything centered around 0 right here with no relationship, that's basically what you're not looking for. Okay, so let's go ahead and just comment that out for now. We're going to get rid of this because it's bad. It's a bad example. So instead, we're going to use the population skew and maybe even the percent change of the population skew as examples here. This is a little bit of a scatterbrain video. You know, it's Saturday, so I'm just going and messing around. I mean, I figured I'd make this video because it's kind of interesting. It might help us out in some way. These 2D histograms are going to be very helpful though for like machine learning. So basically what we're doing is we're looking for feature columns to feed into a deep learning algorithm. If you can find any relationship between a study variable and a future return on investment, that's obviously going to be a good feature to use for a machine learning algorithm. That's basically what I'm looking for here. I haven't been able to find it yet, but that's why I'm asking YouTube. You know, maybe you guys can point me in the right direction here. So let's go ahead and use population skew as the study variable. So skew, we're gonna need another import scipy dot stats as sp. Okay, now we're gonna need to create a function. We'll just create it at the top here. Define s. Kind of a bad name, but whatever. And we're going to be passing in the closing price. So we're also going to need to import from collections import dayq. So dayq is just a moving list. Now skew dq skew dq equals dayq, max len equals 600. So actually we'll go 100. So the population size is going to be 100. Skew dq is just a moving list, so we're going to be appending to this list, and it's going to be moving through our data set. It's going to be 100 in length. So in this function, we're going to be appending to skew dq close. Okay, now is where our logic comes in. So if len skew dq equals 100, then we're going to calculate the population skew. S equals, actually we'll call it skew equals sp dot skew. Now we're going to pass in the skew moving list, and we also have to specify bias equals false. You statisticians out there, go ahead and let me know what that means. Now we're going to return skew. There we go. That looks right. Else we're going to return np.nan. So that's just going to return not a number. We're going to need to also import numpy. Okay, so hopefully you guys can see what's going to go on here. We're going to just use the apply method and apply this function to the data frame. The apply method is awesome. It's kind of like Excel in Python, so if you don't know how to use the apply method, go ahead and learn now because it's very helpful. It's basically like Excel for Python. You know how you put in a function in your cell and then you drag it down to the bottom? That's basically what the apply method is. It just goes row by row. So what we're going to be doing is we're going to be using the supply method for each row in the data frame, and we're going to pass in the closing price from that row to this function s, and then inside of this function, every time it's going to be appending to this list, which is defined above the function. So when this length, the length of this list, is equal to our population size, it's going to then calculate the skew and return the skew. And if this is not the case, it's just going to return not a number and append that to the data frame for whatever column we call it. So now I don't know what happened to my cursor; it disappeared on me. But skew, that's going to be equal to, so annoying, df.apply lambda row colon s row close. Okay. Comma. Really wish my cursor was there. All right. So we're applying this function to each row, and we're passing in the closing price from that row. Axis equals 1. The axis parameter is a little confusing, but let's go ahead and run that and see if we get any errors. Okay, we're good to go. So now we will print df.head just to see what's going on here. I don't know where my cursor went. Okay. So if you guys know anything about skew, a negative skew is basically, let me pull up a figure here. Okay, here's a little figure I found. A negative skew, it's going to have a tail to the left, and a positive skew, it's going to have a tail to the right. Not the greatest figure, but that's quick and dirty, right? So we're going to now plot the population skew on the x-axis as the study variable. So we're looking for any relationship between population skew and future return, which probably not likely, but let's go ahead and do it. So instead of 15 SMA on the X, we're going to go with skew. Future return bins Vmax. Alright, so here it is. Yep, just like I thought, not a great example. As you can see, it's still centered around 0, so there's not really any relationship between the skew and the future return. So maybe instead of plotting the skew, we can plot the percent change of the skew. So to do that, we'll go ahead and create a new column called skew PCT change, and that's just going to be equal to df skew dot PCT change. Okay, now potentially this corresponds to future return. I don't know. Let's see. Skew PCT change. My cursor is just being crazy right now. I don't understand it. Okay, what's going on here? Something's wrong. Okay. So this is messing up. There's an outlier in the data set. It's over here, 115, and this one too, and over here. So I'm not going to go through and try to figure out where that outlier is and how to get rid of it, but this isn't a great example anyway, because you can see that it's centered around 0 anyway. I mean, not a great example. This is my first video. I'm kind of just testing the waters. We'll see where it goes from here. I got a lot of great ideas for videos. Future videos are definitely not going to be as scatterbrained. They're going to be more focused. This is just me kind of testing the waters, you know, trying things out. So let me know what you think. If you find anything interesting with this code, let me know in the comments. But yeah, basically the point of this video is just to have a good way of visualizing data rather than just looking at it, you know, in an Excel sheet or something. These 2D histograms are kind of cool to look at, and maybe they'll help us find a feature column for a deep learning algorithm. So let me know, and Sammy B out. I'll see you guys in the next video. None of the content in my YouTube videos constitutes financial advice. My YouTube channel and I are not responsible for any losses you may incur.